All right, what's going on? Today we're doing another LeetCode problem. This one's called search a 2D matrix. It's a medium, so let's get into the problem. We're given an n by n integer matrix with the following two properties. Each row is sorted in non-decreasing order, so in ascending order. The first integer of each row is greater than the last integer of the previous row. So basically, the 2D vector is going to be sorted like this. You're going to have, you're never going to have decreasing values, like going from one row to the next row, all the values will be greater and so forth. So that's how it's going to be sorted. We're given an integer target. They want us to return true if the target is in the matrix or false if otherwise. We must write a solution that's in big O of log m times n time complexity. So basically we can, being that the 2D vector is sorted like this, we can actually write an algorithm. It's basically a 2D binary search algorithm that allows us to find the value very quickly when the input's sorted like this. So taking a look at input output, they're going to give us the values, the 2D vector values are going to be sorted like this. They want us to find the target 3. So basically the idea is going to be to first use a binary search to figure out what row it's going to be in. And then once we know what row it's going to be in, we can do another binary search to find it in that row if it exists. And they don't want us to return anything but true if it exists and then false if it does not exist. So yeah, let's just get into the problem. Or get into the code here. So we're going to have let's see. First, I'll make some comments. So the solution here for this problem with log n times n time is going to be to implement 2D binary search. And I'm just going to do that like so. So the first thing we're going to do is do our outer binary search to figure out what row the target's in. So we can basically, we're going to need 2 pointers, right? So the top, I'll just have that corresponding to 0th row. And then bottom, I'll have that corresponding to the bottom row, which we can get with the size of the matrix. So matrix dot size. So that's how many rows are in the matrix. And we want that to be the last row, so I'm going to subtract 1 from that. And then we're going to also have a mid row. And at first, we don't need to set that to anything. And we're just going to loop while the bottom row is greater than or equal to the top row. By the way, if you haven't seen the video I have on just regular binary search, it's just called binary search, I would watch that one first. But anyways, yeah, because this is really just 2 binary searches, right? So while bottom is greater than or equal to top, the first thing we're going to do is set the mid row, or calculate the mid row. So the simpler formula for that, I was using a bit of a longer one that I derived on my own, which is actually not the shortest midpoint formula. You can actually just add the bottom and the top together and then divide it by 2, and that gives you the midpoint. So I don't know why I didn't think of that, but yeah, so we can do it quickly, a little bit more easy to read that way. And then we're basically going to check, instead of checking if the target has been found first, we're actually going to check the other conditions first. And other conditions being, basically we want to see if our target value is going to be greater than the, let's see, this is going to be matrix at the mid row, and it's going to be the last element in that row. So basically, if the target value is greater than, let's say we're at this row and our target is like 25, we want to just see if the target's greater than this value. We want to see if the target is basically in any of the rows with that have greater values, or see if it's in any of the rows that have smaller values, but we're going to rule out that it's in this row first. So matrix midrow.back would be this element, and then if that's the case, then we can just set, and I'll make a, actually there's going to be quite a few lines here, so I'll do this in one line. We're just going to set the, let's see, it's going to be the top is going to be equal to the mid row +1. So we're just adjusting the top and bottom pointers. So likewise, else if our target value is less than the matrix at mid row dot front, so that first value of that row, then what we do in that case is we update the bottom value to be equal to the mid row -1, because we don't need to consider that mid row anymore, just all the rows below it or above it, however, whichever orientation you're imagining the 2D vector. So nevertheless, bottom equals mid row -1. Now the only thing that can happen at this point is we've basically checked, is the target value going to be above that mid row, or is it going to be below that mid row? Well, if it's neither of those, we can assume that it might be in that row. So the last statement here, and I'll just create a Boolean variable here that says did find row. So that'll be did find row, and that'll be just false at first. Now, if we got past these two statements, we know that we found the row, maybe. So we can say did find row, that's going to be true, and we can stop looping, so break. Okay, so we're just going to have a condition here now that's basically just going to ask, did we find that row? So if we didn't find that row, we can return false, right? Because there's nowhere, we basically didn't find a row that the target could be in, so they just want us to return false. Now the next thing to do is just do another binary search on that row. So same thing, we're going to have a left pointer and a right pointer. The right pointer will point to the last element in that row. So it's going to be matrix mid row dot, let's see, that'll be dot back to get the last element, and -1, or let's see, actually it'll be dot size -1. We want the size, so that'll be the last element in that row. And then we also want the midpoint, and again, we won't set that at first. We're going to have a very similar algorithm. This one will be pretty much identical to the other binary search video I made. So basically we're going to say while the right pointer is greater than or equal to the left pointer, and we'll calculate, let me zoom out a little bit, we'll calculate the midpoint next. So I'm going to clean this up a little bit now that we have more space to work with. So we're going to say while the right pointer is greater than or equal to the left pointer, we need to update that midpoint position. So it's just going to be the right. Let me put that in parentheses. It's going to be the right plus the left pointer divided by 2. And then now we're going to check, we're going to do this, these conditions a little bit differently for this. I'm going to first check if we've found the target. So if the target is equal to the matrix at the mid row at point midpoint, then we know we found the target, so we can just return true, because they just want us to return true when we find it. Else if, now we can check the other conditions. So if target is greater than the matrix at mid row at midpoint, then we want to shift the left pointer to be equal to the midpoint +1. Else there's only one more condition, and that's when the target is less than that point. So we can just shift the right pointer to be equal to the midpoint -1. So at that point, we can just return false, because if we get through all of this code and the right pointer and the left pointer overlaps the right pointer, we know we never found the target in that row that we thought it was in, so we just return false. For the time complexity, this is going to be big O. So this is going to be big O of log m. So this would be big O of log m. And then this, a binary search, would be big O of log n. And those would just be added together. But remember, when you add logarithms together like this, well, actually, this, I didn't write this correctly. This would be, so this is what I'm getting at. So we have log m here for this first binary search, log n here. When you're adding logarithms together like this, or elements of equation that are wrapped in the logarithm, you can that just simplifies to log m times n, basically, like they were requesting. So hopefully this helps you understand this problem better. If it did, please leave a like and subscribe and all that stuff. Let's actually make sure this code works before I end this video, because that would be awkward if it didn't. So let's see. Yeah, I'll just try these test cases first. So yeah, so it accepts those test cases. Let's go ahead and submit that to see the percentages also. I was getting a little antsy there. So it'd be 20% with runtime, 48% with memory. So, good enough. You could probably mess around with this and get it to be a millisecond or two faster. But yeah, so anyways, thanks and peace.